We'll keep chatting. Pause
My
the
lighting
recording.
is okay?
Yeah, your lighting is okay, sir. The camera can go rise up if possible. You can. Gentlemen, welcome. Yeah, once again, since it is now recording. Good morning, everyone. I just wanted to introduce NFE. I know most of you are familiar with National Federation of Engineers for Electrical Safety. I'll just take 2 minutes just to introduce what we are and where we are heading. So, in less than 18 months, I was just telling our speakers also, we have completed 20. Yesterday was the Hyderabad workshop. With that, we completed 28 physical seminars. And we connected eye to eye connect when we say over 10,000 people that we are connected in throughout this country. So length and breadth we are traveling. Average two seminars average month that we are doing. And webinar, this is our 187th webinar from NFE platform. Again, we connected over 50,000 people through webinars. This is the track record of NFE, and we are one of the fastest growing society in India. In less than 18 months, we have over 1,600 members now, and we have 7 chapters across the country. That is a speed that we are working. I would say lightning speed. Okay, length and breadth we are traveling, and you've seen every day we have different. Every week we have a different subject. Soon we're going to talk about lightning also next week. So this is what is the objective of NFE. Those who are not aware of NFE, it is a non-profit organization uh, to create awareness on electrical safety. So it is for better tomorrow. We started this association. Our vision and mission is very clear. We want to make every electrical installation free from accident, such as electrocution and fire due to short circuit. You would have seen, I am from Bangalore, Ramani sir is from Bangalore. You have seen one of the largest medical institution called MS Ramaya. ICU, fire in ICU. I don't know how many fire we have witnessed in ICU over the last 2-3 years. Um, Nobody knows what exactly happened. They blame it on short circuit. So that's the reason. If you look at our vision to increase the reliability of the electrical installation, that contributing to saving life. We lost one life in that yesterday's accident, and also more than the tragedy is not only we lose life, and also the production of that unit or the operation of that whole unit get into you can't until you put back the report investigation over. So the which means that ICU cannot be working in that hospital for some time till you complete the investigation. So the property loss, the human loss for ignorance is huge. That's the reason NF is there. Our mission is again focus on electrical safety by design, manufacturing, installation, maintenance of electrical product, installation and competent and qualified manpower using quality resources. Today we are going to talk about how important the standards are. And I would welcome everyone, those who are not member of NFE, please do join. If you're an individual, you're a corporate, we are MSME, just 1,000 rupees a member. I keep saying that it is not a cost to anybody. We spend so much money for our own entertainment. Just take out one of your lunch with friend and become a member. So you're enlightened by this various program that we do. And also, people ask, can you share the recording of this webinar or PPT of last seminar? All these are available in our website, www. If you go to this website, so you'll find everything. There's a blog here. The blog will give you all the information, all the presentation, but it is only for member. If you're not member, you will not be able to access to all this information. So hence, I request you to go through this, become a member and able to access to a lot of information. And just wanted to share you some of the last 1 month, what all we did. Electrical safety in hospital. What you see, the image is an ICU. So This is, I think, our fourth or fifth webinar we did on electrical safety in hospital. Then we spoke about power quality measurement. We talk about harmonic and switching transient analysis. And we also spoke about CA regulation. And today, we are going to talk about IEC 61439. So we have very esteemed guest today, well-known speakers. So once again, good morning to everyone. Welcome to this webinar on switchgear and control gear assemblies as per IEC 61439. My name is Dominic. I'm one of the founding member of NFE, and I take care of marketing and events of NFE. So I'm very delighted to have you all today. So in today's webinar, we'll explore the standards that ensure safety, reliability, and performance of low voltage switchgear and control gear assemblies. This standard is crucial for maintaining high quality and consistent practices in the design and verification of these assemblies. So today, our speakers will cover a key aspect of such design verification, routine verification, and the form of internal separations. Our goal is to provide you with comprehensive understanding of how these standards impact our industry and the best practices for implementing them. So, ladies and gentlemen, I encourage you to engage with our speakers. Put your question answer. Okay, this is just a 1 hour 30 minutes webinar. I would request your complete attention to this topic and put your questions there is a Q&A box down. You can put your questions there and our moderator, Mr. Gopakumar, will take the question answer. So thank you for once again joining and looking forward. And our moderator, everybody is aware, he's the president of Gopakumar, and is a member of ETD 20. BAS is one of the most active member in BAS in ETD 20, ETD 30, ETD 50, and also is a member of National Building Code Electrical Committee. He's also IEC TC 64, TC 81, and AC 37A. And we have our second speaker, of course, after Abhijit will speak, Ramani Mani, who's well-known face again in the panel manufacturing. Ramani is also a member of NFE and from engineering graduate from 1983 batch of AC College Technology in Chennai. So he commenced electrical trading business in month on after his course completion in Bangalore. So today his business include the following comprehensive heads like Money Sales, Load Controls India Limited, Mardu Tech, and also is manufacturing. As I am aware that he is very actively manufacturing control panels. So his group turnover exceeds more than 100 crores with 200 employees. So he has led many leadership position in the past in a different forum. As present is a director of COSMA. It is called COSMA. Yeah. The Control Panel Switchgear Manufacturer Association is also a member of South CEO Club of IMA, Indian Electrical and Electronic Manufacturer Association. Welcome, Ramani sir. I'm sure he'll be enlightening the entire audience. And we have a regular speaker, Abhijit, a very active member of NFE and CWC member of Mumbai chapter. Abhijit is seen and is quite familiar. And he's a certified energy auditor with BTech from VNIT Nagpur and PGDM from Belinka. And has extensive experience in electrical engineering across various roles. He was in Siemens, PCA System, Amar Raja, Hager India, and ABB. Currently is the senior consultant VL engineers specializing in electrical distribution design and passionate about Industry 4.0 and energy efficient systems. So these are our speakers for the day. And as I said, I would request everybody's attention today's topic. I would welcome Abhijit to start the session, followed by Ramani sir will take up, then Mr. Gopakumar will come and moderate the whole session. Thank you. a wonderful session. Over to you, Abhijit.
Yeah, just a moment. Yeah, just let me know once my screen is visible.
Yeah, it's visible. You can make full screen.
No problem. I'll just make full screen.
Lakshmi, you can make a speaker and slide. View, go to view, and you can side by side, you can make it.
Yeah, just let me know once it's visible in full screen.
Yeah, it's you can you still it is you can see the slides. So just click on the full screen on the right side corner.
One moment. I'll just right side corner.
Yeah, you can see the full screen down corner. Yeah, just move on.
Anyways, I'll just start on this. Can I start on this?
Yeah, if you can make full screen, people will be able to view. There's a full screen on the down. Come to bring the arrow down.
Yeah.
Yeah,
Is it
you can.
visible now?
नहीं up नीचे आओ ना. Come there. You can. There's a full
One
screen
moment.
option.
Where? Just one moment. I'll just check this again. I'll
Are
stop
you right?
sharing and restart.
Right side, right.
One moment. Share this. Okay, right side full screen. Zoom window.
No, come down. I can see your screen. There is a full screen option. नीचे आ जाओ, where you can zoom in, zoom out. That first screen on the left, so you can see the full
Here.
projector.
To the percentage.
Right side. This one here.
No. Next to that, there's a screen.
This one.
Next to that, zoom in minus plus है ना? Minus के next
Right.
one. Yeah, that
This
is
one.
the one. Yeah.
Okay. Okay. Now is it visible, the full screen?
नहीं. अभी click नहीं किया.
I did click it. Yeah, just let me know once it's full screen.
Not happened, Abhijit. Or go to the right side. ऊपर है ना?
I'll just do it once again. Just repeat this.
No, you can on the screen also you can right click and you get option, make it full screen. It's very easy. I don't know because you have done.
Maybe
I don't know. You're sharing the full screen of the view.
Can you see this now?
नहीं. You're sharing the program screen दिख रहा है.
Okay.
Please unshare that.
And share this.
F5.
Yeah, F5, no?
Yeah.
Press F5.
I've pressed F5.
I don't know from where you pulled out this presentation. I told you to make it, minimize it, and.
Okay.
Anyway, go ahead with the screen.
I'll go ahead with the screen. Let's not.
Yeah, please go ahead with the same screen.
No problem.
Hello.
So,
Dominic,
yes, sir.
Okay, now I think, Mr. Abhijit, you shared the screen or you shared the file?
I shared the window.
Window. No, you unshare and you share the screen.
Okay, one moment, sir. I'll share the screen. Okay, entire screen.
Yeah.
No.
You once when the new window comes, then you can now you open the file and put it on.
Okay, now I open this.
Put it on full screen. Yeah, now it's perfect. Perfect.
Sure, wonderful. Sure. So good. So anyways, good morning all, and welcome to today's presentation on IC 16439, which I call as the guiding standard for enclosures. Now, why do I call this a guiding standard? Is because based on various rules and regulations, now this has become the standard which we should be following for all the testing as well as installation and design of enclosures. Just to understand why IC 16439 is so important, we are all aware of Indian electricity rules, which have setting up procedures for generation, transmission, distribution. and Indian electricity rules are also mandating following CA regulations 2023 for the supply and use of electricity. I think all of us, we have had a lot of discussion on CA regulations, and all of us know the mandatory clauses and applications of it. We also know that the National Electric Code is now forms a part as the primary design and installation standard for India. So anything we are designing or installing, we are supposed to follow the National Electric Code. And within the National Electric Code, there is a list of product standards which are to be referred during design and installation. Now, for all of those who have been through the NEC, who have referred it multiple times, you will realize that IC 6149 has been referred a lot of times. Multiple times you'll find reference of IC 6149, whether it is for panels, whether it is for bus trunking systems, whether it is for distribution boards in your houses. Everywhere you'll find a mention of IC 6149, and hence I call this as the guiding standard for enclosures, because this will guide us in terms of how enclosures should be installed and designed. Just to understand the various parts of 6149, so 6149 currently consists of 7 parts. Part 1 forms the general rules. Part 2, which is one of the most comprehensive ones, that is forms the part of switchgear and control gear assemblies. Part 3 forms for distribution boards, that is the distribution boards we install in our buildings, residential, commercial. Then there is a part for construction sites, power distribution networks, bus trunking systems, and special assemblies, one of the prominent ones in that being electric vehicle charging. Now, 61439 now is the only standard in India which we need to refer. Earlier, we used to refer standards like IS 8623 Part 1 as well as IC 60439. These are no longer valid in India, and these have been superseded by IC 6149 as the primary standard. 6149 insists on testing the complete assembly with switchgear inbuilt. The earlier standards had a provision where you could test the enclosure separately, the switchgear separately, and then you can have the assembly as a complete compliance. However, it's no longer applicable with 6149. 6149 insists on testing assembly with switchgear, which means if your enclosures are tested with switchgear A, the same philosophy, the same design may not be applicable to, with, let's say, switchgear B. You'll have to make certain changes in order to ensure that all the parameters that you have tested comply to it. Also, this sets up various definitions. So original equipment manufacturer, assembler, specifiers. You might have a switchgear manufacturer who has a design, who has franchised it
Started.
further.
Oh yeah, mine will take another 15 minutes, 10 minutes or so.
And then these can be assembled by a assembler who gets the design. Similarly, it also sets up definition for specifiers as well as switchgear manufacturers. Another important part in 6149 is that earlier you could only verify your design through testing. However, 6149 provides the flexibility. You can have compliance through testing, through comparison, that is comparing to an already tested design and maybe trying interpolation or extrapolation to have compliance with, as well as evaluation of the design through calculation. So 6149 also shares some calculation criteria through which you can provide compliance to this standard. It provides few additional type tests or rule standards. We'll go through it. And most importantly, it augments electrical safety. So when I say augments electrical safety, all the earlier standards for panels spoke about electrical safety by protection to short circuits, to earth leakages, to overloads, but very few standards insisted on operator safety. Now, operator safety is also considered a very, very important part in 61439. So we are all aware that these standards are all interlinked with one another, and 6149 takes the best practices from multiple standards and incorporates them in the criteria. So it takes a reference from 60364 4-41 for protection against electric shock, where I say operator safety, 603647 for requirements for special locations, 60664 for installation coordination and dielectric testing, where the dielectric strength of the panel and switchgear are tested together. IC 60529 for ingress protections, PN 50110 for operation of electrical installation, 60204/1 for safety of electrical equipment, 50270 for protection against direct contact, again an important standard for operator safety, and 61641 for protection against internal arc as well as arc flash. So you can see that 6149 has derived a lot of safety regulations, safety standards, criteria from various standards, and hence it is a clear upgradation for safety over the old standards. Now, 6149 compliance will ensure that your enclosure is suitable for any application. So when I say various parts of 6149 already take care of specific applications, we'll see few of them in the coming slides. Similarly, other panels like APFC panels, if you're making APFC panels under 16636 or IC 61921, all the criteria related to enclosures come from 61439. Now, there would be some additional criteria to, let's say, capacitors, to reactors, to thyristors, but the enclosure criteria come from 6149. Control panels or safety panels under 60204 also has similar criteria to 61439. Hazardous area panels also take the criteria from 61439 and add a few more to it. VFD enclosures also follow the similar criteria. Now, let's say you're putting a VFD in a conventional panel and you're having calculations for additional heat losses through a VFD enclosure, you can extrapolate a 6149 design to suit to, let's say, VFD application, a capacitor application, to hazardous area application with certain additional, let's say, changes. So I would like to say that if you have a design, if you have a panel which is 6149 compliant with some modifications, with some additional criteria, it could be made suitable for any application. Now, coming to the special applications which are listed under 6149. So 6149 part 3 talks about distribution boards for use by ordinary people. Now, what do I mean by ordinary people? If you take 6149 part 2, it talks about switchgear and control gear assemblies which are predominantly used in industries where the operator would be either skilled or would be an instructed person. However, when it comes to distribution boards in buildings, you will have neither skilled nor instructed staff. You will have common residents or common office users who will be using these distribution boards. And hence, a much higher level of electrical safety is needed. Now, this standard limits itself to an incomer of 250 ampere and maximum outgoings up to 125 ampere. And hence, it only is limited to protection devices like MCBs, RCCBs, RCBOs, arc fault detection devices, etc. However, it again, similar to other parts of IC, it insists on integrated testing of complete assembly. So in case if you're getting a distribution board by a manufacturer A, it would be tested as a complete assembly with the MCBs, RCCBs also coming from the same manufacturer. And hence, a complete integrated electrical safety is available only if you're buying distribution enclosure from one party and also the switchgear from the same manufacturer. If you're going to be changing, like what I say, device substitution for distribution boards. So you're buying distribution board from manufacturer A and putting manufacturer B switchgear into it. It may not pass the same test and it may not offer the same level of safety. You might have to retest it again in order to ensure that you're having it. And since we do not follow it, I would say for this specific use for distribution boards in buildings, we should be following same manufacturer for distribution boards and internal components. Moving to part 4, which is typically deals with construction sites. So these panels are used in construction sites like civil infrastructure, like buildings, roads, highways, dams, etc. Also for demolition and excavation. Now, these panels which are used in these applications could be portable, so I call it mobile or semi-mobile. However, they have to withstand far more severe service conditions. So, 6149 Part 2 enclosure might normally either sit in a electrical room indoors or it might sit in a shade outdoors. But the criteria needed to pass 6149 Part 4 are going to be far severe. So you might need a much better IP class. So instead of IP4X or IP5X, you might need IP6, 65, 67, 6X panels. You'll need far higher mechanical strength because demolition work might be going on, construction work might be going on. It will require higher corrosion resistance because you might be working in areas which have salty environment, which have higher pollution degree. Also, since many of these panels would be outdoor, they would require to be tested for UV protection and also impact resistance. So an indoor panel may have an impact resistance of, let's say, ICO 07, and it could pass for use in industry, but for use in outdoor, I will require an impact resistance, let's say either IK09 or IK10. In these specific panels, it is mandated that access to the internal devices should be limited by locking arrangement. In such severe conditions, this switchgear need not be exposed to these severe conditions. If you have an enclosure which can be locked and then which can have the IP, the mechanical strength, the impact resistance as tested by IC 16439, only then the performance can be guaranteed. Hence, these panels need to have limited access, so no unauthorized access is mandated in these panels. Part 5, this is, I think, I have not seen application of this in India. This is what we call as public electricity network distribution assemblies, also known as PENDAs. So PENDAs are quite popular in Europe. They are also popular in Middle East, where it takes power from multiple sources and then distributes it to individual customers. And it will have certain diversity factors defined to it. Now, in case if we are going to be using similar standard in India, then we might have to test it, or it might have to withstand a very wide variety of temperature. Now, if let's say you are installing it in a location like Kashmir or Ladakh, where you might have temperatures as low as minus 25 degrees, or an area like Rajasthan where temperatures extend to 50 degrees Celsius. So the panels have to have guaranteed performance in this wide temperature range. Similarly, PENDAs always may not find a good location to install. You might need to terminate overhead lines into a PENDA, which is not normally the case with industrial panels or even panels in buildings. And similarly, PENDAs might need to be installed directly on transformer flange in case of compact or pad-mounted substations. Hence, all these tests, all these criteria, installation criteria need to be explored. And thus, IC 6149 Part 5 provides us a possibility of even extending enclosures to public distribution networks. The Part 6 is another important criteria, bus trunking systems, where these days you can see that bus trunking systems are replacing conventional PDB-based distribution at a lot of places. And hence, we have to ensure that these bus trunking systems comply to 6149 Part 6. So again, similar to panels, bus trunking is considered as a complete assembly, including the conductor, expansion joints, bends, tap-off boxes with switchgear, and hence the current capacity of these has to match everyone. So temperature factors related to everyone, mounting factors, whether it is mounted horizontal, vertical, under what kind of support. So all these factors are needed to derive at a current capacity, and it needs to be tested that way. Similarly, this part specific of 6149 also insists on fault loop impedance calculations, because without it, it is very difficult to determine what would be the fault withstand capacity of the bus trunking. And again, bus trunking system has special mechanical strength criteria because it will be installed on certain type of mechanical supports, and hence the load, the impact capacity, as well as bus trunking system is installed parallel to one another, the magnetic effects because of it. So all these things need to be taken into consideration while testing a bus trunking system under 6149 Part 6. So what does 6149 seeks to achieve? Now, since we have set up such stringent criteria and installation criteria into this, what does it seek to achieve? It seeks to promote fair competition by having uniform specifications. As we know, globally, every country will have its own standards. So India has IS, USA has NEMA, China has its own standard, Japan has its own standard, Russia has its own standard. So there needs to be a platform, there needs to be uniform specifications, and IC 6149 provides design criteria which can suit globally. Similarly, it insists on operator safety along with equipment and personal safety. It is improving performance of the panels, and hence, though 6149 compliant panels might require higher initial investment, they do have lower life cycle costs, so lower maintenance and better performance than a conventional panel. It has flexible testing procedures, and all kind of innovations are promoted. So you can have different innovative switchgears, different innovative assemblies, and then you can get them complied by through evaluation or through comparison. Similarly, it brings all manufacturers on a common platform by ensuring that each of them provide the same in-panel performance. Now, what does 6149 provide to specify? So, since I'm a consultant, I would always be looking at certain benefits which I would get from 6149. So it provides standardization. So once I've made a specification, with, let's say, particular current value, a particular short circuit value, and some kind of form of segregation, I would have a guarantee that whichever manufacturer I buy it from, if he's 614 compliant, my in-panel performance is guaranteed. Similarly, not only the current performance, thermal performance, but also the mechanical strength remains same throughout. So you will have commitment to both thermal as well as mechanical performance for a panel if it is 614 compliant. Similarly, if I am having various applications, so whether it is indoor or outdoor, it provides flexibility. It has different type tests for an in panel, an outdoor panel, a panel at construction site, as what we have seen earlier. And again, ensures electrical safety. Now, I'll insist on this multiple times. IEC 6149 is adding electrical safety not only to your equipment but also to your operator. And hence, a specifier would always be more than happy to insist on 6149 compliance, because it is helping not only the user but everyone who is involved in the project. Similarly, for end users, since IC 6149 is a standard design, it has little to no customization in it, and hence any person who is making 6149 compliant panels can have the standard design and can have very fast assemblies, and hence you can have faster delivery lead times with 6149. A lot of times people say that results obtained during factory testing as well as site testing do not exactly match up with the type tested design. But with 6149 providing very stringent criteria, you can rest assured that whether a factory assembly testing fact results will be similar to what the type tested results are. Again, designs are scalable since 6149 talks about calculation and verification. The panels can very easily be extended. Panel designs can be changed subject to certain calculations, and hence it provides a sustainable design with low maintenance. Similar to what I have said earlier, again, 6149 is adding to safety, and hence it's a very, very important practice. A lot of standard safety practices have been already integrated in the application, and hence a user who is installing a 6149 panel can have a very sound sleep at night, knowing that his operators are safe. One of the criteria which I'll just like to touch upon is device substitution, where 6149 typically says that if you're testing a design made with switchgear manufacturer A, the same cannot be extended to switchgear manufacturer B. In the Indian interpretation, we do not allow device substitution, but certain other countries do allow for device substitution subject to certain calculations. So these calculations may be related to things like heat losses or maybe current carrying capacities, in-panel performance, etc. However, in India, since this standard is a guiding standard and till date it has not been exactly made mandatory by the regulators, we might try device substitutions. However, I would still discourage you from it because it should only be made when backed with verifiable calculations. So if you're going to be using the same enclosure with another switchgear, you should have some verifiable calculations backed by it, calculations as per IC 6149 to ensure device substitution. Now, I think I've mentioned this form of segregation. So these are forms of segregation of panels. So as you can see, this is form 1, which we call as a complete non-compartmentalized design. This is form 2A, where the switchgear is in another compartment and the incoming and outgoing may be in the same compartment, either same compartment incoming outgoing or same compartment with switchgear and outgoing terminals. The form 3A and 3B are panels which we normally see in industries, where you will have switchgears installed in compartments, either with a common cable chamber where incoming and outgoing cables come, or with separate cable chambers for incoming and outgoing. And form 4A and 4B are also seen in industries, also in certain very special applications like data centers, where there is a complete segregation between the panels, between the switchgear, and also even the control wiring is made through a different chamber. Now, as I mentioned earlier, a lot of tests have been added in 61439 for strength of materials, for incorporation of switching devices, for testing of external conductors, dielectric tests, for EMC. EMC is another important test because these days we are having sensitive electronic equipments and we are having harmonics in the system, and these can interfere with one another, and hence your panels also need to be EMI EMC compliant in order to ensure the right performance. And also mechanical strength was not a criteria which was insisted in the earlier standard, but it is very strongly insisted in 61439. And similarly, this gives an option in terms of how these tests can be verified. So some of these tests, like let's say strength of mechanical strength, clearances, creepage distances, dielectric properties, mechanical operations can only be done through testing. However, certain tests like temperature rise, short circuit, if you have a already tested design, you can do extrapolations into it, or you can have a design where you can make calculations, and then these tests can be complied to, subject to the right calculations or subject to the right references. I think that's more or less from my side, and I'd like to hand it over to Mr. Mani to take this forward. Thank you. Thank you very much.
Thank you, Mr. Abhijit. Over to you, Mr. Mani. You have to unmute yourself.
Lakshmi, can you kindly go ahead with the screen sharing? Yeah, possible to make it bigger?
If it's a PDF file, you press Control L.
Huh.
Control L, then it becomes a full screen. Control L.
And also, if you can make the screen to be exactly the size of the window.
Yeah, okay, now it's perfect.
Yeah, great, thanks. So, very good morning to all of you. It's such a pleasure to see 240 people in this webinar. And thank you, NFE, for extending this invitation to me. And I've just become a member of NFE, and I look forward to seeing how one could together add more value to the aspects of safety, reliability, and convenience in the electrical systems. What I chose to talk about, on the subject of IEC 61439, considering all the dangers and the not so great practices which are leading to fire hazards and losing of life, materials, and so on and so forth, is that we must recognize that there are two types of panel builders. One is the compliant panel builder, and the other is the careless panel builder, the person who cares a little less when it comes to the quality aspects of safety. So the next slide we'll see as we go forward. I'd like to explain this more, but before that, a little about myself to set the context. I started business in the year 1983. This is about 41 years ago, straight out of college. Started off with an electrical trading company, Money Sales Bangalore. Today we are amongst the top distributors for Legrand in South India. We are also significant stockists for ABB and Socomec, and we are distributors South India for Electron. In order for me to move from products to solutions, I started in the year 1990, Load Controls, switchboard manufacturing company. Today, we manufacture both low voltage and medium voltage switchboards with partnerships with Schneider. For power factor, we have TDK. We are one of the biggest partners of Modutech, and we manufacture motor control and power control centers, bus ducts, so on and so forth. And one of the things which happened as a panel builder was I stumbled upon this technology of modular enclosures. Previous slide, please. And in this modular enclosures, I realized that there was a huge amount of standardization and scaling possibility when it came to the enclosures and therefore the switchboards, and hence the foundation of the third company, Modutech, which today we are also branding for two multinational companies and growing from strength to strength. So coming back to IEC 61439, this is a standard. I would like each and every one of us to appreciate that it is mandatory as a legislation in the European Union, in UK and Australia. So you can well imagine that it is only a matter of time before India too makes this mandatory. If you look at, if you are a panel builder, you would agree with me that probably just 5 years back, when 10 inquiries were received, hardly 2 or 3 would ask for IEC 61439. But today, the number has moved to 7 to 8 out of 10. Earlier, it was only the major cities where people were aware of the standard and wanted to follow it.
Mr.
But
Mani,
today, even in the, yep.
Mr. Mani, 1 minute. Sorry to interrupt you. Sorry to, because I would like to make an important, message to all the participants.
Sure.
This standard 61439, it is not only mandatory in Europe or other countries. It is legally mandatory in India as well, because in 2023, June 8th, the CEA regulation, the latest Central Electricity Regulation has been published. Regulation 14.2 says NEC, NBC has to be made, they are made mandatory, shall be followed. And sub-regulation 3 says, every product used in the electrical installation shall be as per IS standards. And now 61439 part 1 to 7 is already an Indian standard. So compliance to the standard or compliance to 61439 is already mandatory, legally mandatory. Thank you very much. I just would like to add.
Thank you. I stand corrected and appreciate that. It's a very good development, and I couldn't be more happier. So I was talking to you about how the standard is moving from cities to 2-tier cities, and then even if you look at projects, we find that from the oil and gas and data segment, data center type of jobs, it's also going into the building and industry. And I'm very glad that this is today we're going to be seeing more and more of IEC 61439. Probably it'll move to 10 out of 10 in the tenders, as what Mr. Gopakumar said, and let's hope for the best. Next slide, please. So in order for us to really reach out to the panel builders across the length and breadth of our beautiful country, as well as the length and breadth of the entire globe, I would say that there is a lot of educational marketing which is required. COSMA is the Control Panel and Switchgear Manufacturers Association, and we do a lot of work in this regard. NFE, the National Federation of Engineers, as you can see, this is a beautiful platform which has been provided by it to disseminate this knowledge even further. IMA, the Indian Electrical and Electronics Manufacturers Association, is also doing yeoman service in the areas of taking standards forward. SEMA, the Consulting Electrical Engineers Association of Maharashtra, is also conducting a program called SEMA Tech. It is on 5th of October, and then 2 more shortly after that, again with the intention of seeing how we can reach out to the nook and corner of the country. Social media, white papers, exhibitions, seminars, and webinars like this, all of these will need to be seeing more and more of reaching out to people as we go forward. Now, the most important aspect of IEC 61439 is that it builds trust. And this trust is very important. And where does it start? It starts with the client defining his need, and he declares his budget to the electrical consultant. The electrical consultant takes this brief, and then he advises the client on the pros and cons of how the tender should be worked out and the importance of compliance. And then it comes to the panel builder. And here again, as I said, we have the compliant panel builder and the careless panel builder. So with all respects to panel builders, this is something which we really need to be doing a lot of introspection on and seeing how we can improve things. Next slide, please. So when I say compliant panel builders, what I mean is if you take an aluminum bus bar or a copper bus bar, you have electrolytic grade and you have commercial grade. And mind you, when you look at it, you'll not know the difference. But the price difference is around 40%. And therefore, you can well imagine how important it is for a consultant to ask the panel builder for the electrolytic grade test which has been done. ISI marked wires, ideally with being halogen free in terms of the insulation. This is something which is very important, but how many consultants and how many end users are aware that there are non-ISI grade wires and compromised in metal alloys and the insulation? These are things in which goes even up to the lugs in terms of sizing, in terms of the material. So it's very important for us to recognize that safety is everyone's responsibility. And the ones who go for short-term goals and the benefits of quick wins, we have to see how to control them in our entire ecosystem. Next slide, please. So the big differentiator, please one slide back. The big differentiator between IEC 60439 and 61439 is the fact that 61439 not only allows the enclosure to be tested along with the switchgear, which is very important, so it becomes one big comprehensive unit, but it also allows for verification by testing, verification by comparison with reference design, and verification by assessment. So there are multiple ways in which one can arrive at the compliance, which is a very good thing. Next slide, please. So this is something, where the entire 12 tests which are presently there in 61439 can be divided into verification of construction as well as the verification of performance. And each one of these are available in detail in the standard. And it's I'll be touching upon the major points as we go forward. Next slide, please. So the important distinction which consultants and end users will have to identify with is the definition of an OEM manufacturer. And I find that this is quite misunderstood in the marketplace today. According to IEC 61439, the original manufacturer of a switchgear and control gear assembly is the organization that designed and verified the assembly, which means, for example, Modutech. You could also put in that example Schneider or ABB or LK or whatever. But the important point is we have to recognize that when the enclosure manufacturer and the switchgear manufacturer comes together, it's not just the switchgear manufacturer who qualifies to this positioning of an OEM manufacturer, but it is anyone who designs and gets his design verified as a switchboard, he becomes an original manufacturer. To that extent, Aero Electricals or Marine Electricals are also OEM manufacturers. And then we also have the original. Okay, let me go forward. So we have, in order for us to understand this entire aspect of IEC 61439, here's another shout out to all consultants that my recommendation is that we'll have to follow the standards which are advocated by all the advanced countries. What do? They ask the panel builder to submit the declaration of compliance. Now, what is the declaration of compliance? The 12 tests which the IEC 61439 talks about, we need a declaration as to how each panel which is supplied to a particular project is compliant to each of these tests. And this is the format in which this compliance has to be given. And my earnest appeal is that consultants should insist on this declaration of compliance coming from the panel builders. Next slide, please. Now, we have already spoken about device substitution, and I saw in the questions Mr. Vinod Panchal has asked as to what are the conditions for device substitution. And here they are, that when you say substitute Eaton switchgear with an ABB switchgear, then what happens is ABB switchgear can be used in place of Eaton, but the device power loss has to be equivalent to Eaton or less than Eaton. Similarly, the terminal temperature rise. The terminal temperature rise is a data which is available with every switchgear manufacturer. That of ABB will have to be equivalent to Eaton or lesser than Eaton. And then the dimension of the cubicle which is being made, it has to be equal to or bigger than the type tested verified design. So if these conditions are met, then device substitution is permitted in Australia and New Zealand. Next slide, please. Now, it's in order for me to run through all the tests one by one, time will not permit. So I thought I should just talk about an 80-20 focus, which are the 20% of the rules which the consultant and the panel builder will have to focus on in order to ensure that the compliance takes place. So number one, we have dielectric properties, short circuit, clearance, and creepage. All of them belong to a kind of a similar family. Now, we see here in the screen that we have the metal conductors shown in 3 parts. And when there is an insulated barrier, when you talk about clearance, the clearance is measured as the bird flies from one point to the other. Whereas when you come down and you see the creepage distances, it is as the ant walks from one end to the other. That is the creepage distance. Now, both the creepage distance as well as the clearance will dictate the kind of voltage which the panel busbar system can take. And today with renewables, we are talking about not just 415 volts, we're talking about 800 volts, and probably it'll go up further. So it's very important for us to understand these things, ensure that the panel builder is writing this out in his technical specifications, and then this gets approved. Similarly, the busbar size, the material, the insulation support, the air volume inside the busbar chamber, all these are factors which impact the short circuit withstand capability of the switchboard. Next slide, please. Now, when you see a panel which is being subjected to a short circuit test, this is how it is assembled and fastened in the laboratory, and before test and after test. So both these situations are looked at, and then whether it is passed or failed, there are various criteria to ensure that one arrives at what is right and what is wrong. Next. Temperature rise parameters from the switchboard, as what you can see in the picture, both at the top as well as at the bottom. The top, you have a 3-meter copper which comes out of the switchboard. Now, it's important for this 3-meter to be there for both busbar as well as the cable. And then again here, for temperature rise parameters, the size and the material of the busbar is important, the air volume is important. Every joint is an important area which needs to be checked, and it needs to be checked for the millivolt drop test. This is critical. Busbars, you can either go for sleeves or you can go for painting. And ideally, if you go for black color, then it absorbs the heat from the busbar, and therefore it gives you a better temperature rise. And then you can have single run of busbar, double run of busbar, but try to avoid 3 runs of busbar, because when you have 3 runs of busbar, the middle busbar hardly carries any current. And then you have different configurations of busbar. You can have interleaved busbar, you can have one on top of the other in terms of 2-tier busbar arrangements. Each one of them have got different distinct advantages, pros and cons in terms of the current carrying capability. And then, the watt loss of the devices will need to be looked into. And if it is IP rating plays a very important role. If it is, what is the more stringent the IP, the more difficult will it be to pass the temperature rise test. So when we come to IP, it's very important for us to understand how the dust test gets done and how the liquid test gets done. So there are, of course, different ways of doing it in different laboratories, but generally the entire panel is pushed inside a huge chamber, and fine dust is sprayed from all over. And then after a while, when the panel is removed back outside and doors opened, you will see whether the powder has gone in or not. Similarly, water test, and it has got different criteria, which I'll come to. So generally, IP 4X to 55 is for indoor, and up to IP 66 is for outdoor. This is the general ones. Of course, you can ask for different specs depending upon your application. And then you have the Yeah, natural and forced ventilation is an important part. You see, it's very important for the consultant to take a specification and read through every page, because what result one gets with forced ventilation is not as good as the result what one would get with natural ventilation. So these finer aspects of IEC 61439 will need to be understood, absorbed, and executed. Next slide, please. These are the different solid entry specifications ranging from IP1X to IP6X. Next slide, please. And then we have the water. Water also coming vertically, coming at an angle, coming at a force, and then submerging the entire panel inside water, and then submerging it inside the water for a particular distance. So all these are the second digit of the IP, which defines the water ingress. Next stage, next slide, please. So this is the various IP ingress protection. We need to understand this. So if you say IP 44, for example, then you say that it is water splashing against the enclosure from any direction on the water part of it, and then objects above 1 mm, the objects actually below 1 mm only. 1 mm is the max. You can't have anything more than 1 mm going inside. So this is how you arrive at the IP rating of an enclosure, and it's very important that each one of us understand it. More importantly, why it is required. For example, when you talk in terms of a cement plant application, then you will definitely need to go for IP54 for indoor, and if it is outdoor, you'll have to probably look at IP66. So depending on the application, at the same time, if the switchboard is going to be in an air-conditioned environment in an IT plant, then probably IP42 is more than enough. So the consultant will have to look at what is the application and then choose the IP rating and put it in the specifications for the switchboard manufacturer to align with it. Next slide, please. Now, there are various other tests which I wouldn't be going into great detail in. There is the resistance to corrosion test. There is the thermal stability of the enclosure. There are certain parts of the enclosure which is subject to thermal instability. So we need to test it to see whether certain minimum standards as set out by the IEC 61439 is passed. Similarly, mechanical impact. If you are using too thin a gauge of the door, then you are not going to be passing the IK10 test or IK8 test, as the case may be. So it is important for us to understand how we need to specify the IK test so that the enclosure protects the electrical switchgear inside and also is sturdy enough to withstand the short circuit, God forbid it happens. Then you have the resistance to UV radiation, which of course is applicable only for outdoor panels. And then how you lift a panel is also important, because when you're lifting the panel should not collapse. So there are certain minimum criteria for that. Marking is an important area on the nameplates as to how it should be legible even 5 years from now, 20 years from now. And then the resistance to heat and fire. So this is different for the current carrying insulators and different for ACB enclosure, for example, which comes in plastic. So each one has got a particular threshold of blow wire test which needs to be passed. And all these are important aspects to be looked into for one to be compliant with IEC 61439. Now, this is a salt spray chamber, which I thought it would be of interest for you to understand as to how the various sample of a switchboard, this may be a small box is made 1 foot by 1 foot by 1 foot and kept inside this salt spray chamber. And then this mist is induced at a particular temperature, so that we have to look at after X number of hours, what is the rust formation? Is it white rust or is it red rust? So these are all certain tests which gets done in the laboratories to differentiate between one who has done a good quality of powder coating or one who has used a good material for the switchboard as against one who has compromised on this. Next slide, please. So IK test is, as I said, it goes all the way up to IK 10, and I'm happy to inform you that all our Modutech type test certifications are with IK 10, and this is important for us to appreciate that this is critical for us to understand. Just like when we buy a car, we have a bumper in the front, and then we ensure that it doesn't get damaged. Similarly, here also you need to have a strong outer enclosure as much as internal structure to ensure that the panel is sturdy and it takes the purpose for which it is being made forward in a proper way. Next. So these are the forms of construction which has already been touched upon by Mr. Abhijit. So I'll pass this. Next slide, please. Yeah. So again, this is a call to specifiers and end users that I would request that you specify. Now that we know that it is mandatory, then automatically we'll be seeing more and more of IEC 61439. But then ask for the complete certificate. Don't just be satisfied with the first page, because the first page only gives you a certain information that yes, it's an entry ticket. But then who is coming with the entry ticket is important for you to appreciate. Whether the type tested panel is with forced ventilation, or whether it is with natural cooling, whether it is with copper bus bar, or whether it is with aluminum bus bar, whether it is in single tire formation of ACB, or whether it has got two tire formation of ACB also, whether it is single front only, or whether it has got double front as well. Like that, there are so many aspects. Somebody asked in the Tanveer Singh has asked that is 61439 with for VFD applications in IP65, is it possible to get it done? There's nothing that is not possible, in the sense that it will only mean that the size of the enclosure will have to be more. You have to do your calculations for your temperature rise. That is the most important criteria to pass when it comes to outdoor enclosures. So these are certain things which one needs to look at with a magnifying glass. Declaration of compliance, as what I had mentioned, is very important for consultants to ask for for the various projects. And then we have modular switchboards. In my opinion, from my experience, I can share that it definitely takes you 10 steps ahead as far as safety, flexibility, and compliance is concerned. And then you select an assembly manufacturer. So an assembly manufacturer is the person who's going to take after your design and then do the assembly. So he also needs to understand how to comply to IEC 61439. And together with the partner, all of us will need to be seeing how to help the customer specify his needs, how to be doing a little value engineering, how to guide him in configuring the panel better. And the routine verification tests, of course, is also has to be a given, whether it is going to be a factory acceptance test or a site acceptance test. This is different from the IEC 61439. Next slide, please. So as an OEM manufacturer or a panel builder, as I said, adding value is very important. We need to be here to make electricity more safe and reliable, and therefore we need to be continuously thinking in terms of optimal designs. We need to select truly certified assembly systems. I'm saying that with a little bit of a sarcasm because unfortunately, in my experience, I have come across people who pose to be certified, but then actually you go into the details, they are not certified. Ask your OEM supplier to train you. This is very important. This training is extremely important, with estimation and design software, assembly and installation guides, quality inspection guide with checklists. And these checklists, mind you, has been evolved over years of experience. And it is very important for us to train each and every OEM partner to also align with the similar thought processes. And then work doesn't get over after the supply of the switchboard. Maintenance and end user guides and checklists are also important. And then when it comes to the design, manufacture, and verification of each assembly in compliance with the project specifications. So how does that happen? The OEM manufacturer's instructions should be clear. and the submission of the declaration of compliance will have to be in hand-holding manner. It has to be taken forward. Now, when you look at IEC 61439, there are the routine verifications also, as I said, which comes as a part and parcel of what a switchboard manufacturer should do in his factory. And here the degree of protection, the clearances and creepages, the protection against electric shock and integrity of the protective circuits, all of this will need to form part of your checklist. And the incorporation of built-in components. So what are the built-in components? What are the technical parameters? In fact, all this information should be available on a QR code, which is put on your panel, so that at any point of time, 5 years down the line, 20 years down the line, by just scanning that QR code, the user will be able to get all these information. And this is very, very critical. It is a best practice which needs to be followed. And all of us have to go from point A to point B, because what got us here won't get us there. So next slide, please. So my last slide, I'd like to thank NFE for this opportunity to evangelize IEC 61439 standards and beyond. I'm also happy to share that, in order for us from Modutech to take this concept to India and the world, we have also appointed Mrs. Brick and Bite, a very good fabrication shop in Mumbai. They are converting almost 200 tons every month as a mod hub for Modutech. So you can see more about them in their website. And this is the kind of certificate we give to panel partners. I'm happy to say that we have 97 panel partners across the country today. Can't wait to make it 100. And so here's an invitation to each and every one of you to join the modular, compliant, and sustainable mission to simplify panel building. Thank you.
Thank you very much, Mr. Ramani. It was a very nice presentation, and the participation was excellent. And moreover, the number of questions in the chat box itself, there are so many questions. So I request everybody who wanted to ask the question, please don't put the questions in the chat box. You are requested to put it in the Q&A box. The Q&A, there is a link for Q&A. Now, to answer some of the questions, I am just sharing my screen. I hope my screen is visible, which is showing central electricity.
Yeah, perfect.
Yeah. I am just taking you to the CEA regulation. All of you know that the CEA regulation is the mandatory requirement for India. This is as per the electricity rule, as per the Electricity Act 2003. CEA regulations are made. I am taking you to regulation number 14. Regulation number 14 explains the general safety requirements of electrical installation. Now, if you look, you see the sub-regulation number 2, save otherwise provided in these regulations, the relevant standards including National Electrical Code and National Building Code shall be followed is the word used. In the previous versions of the regulation, it was may be followed. So may was a recommendation, whereas now it is written as shall be followed, means it's a mandatory requirement. Now, if you look at the clause number 3, the material and apparatus used shall conform to the relevant standard. So this is also clear. Every material which is used in the electrical installation shall conform to the relevant standard. Now, the relevant standard is nothing but our Indian standard. You can go to the BIS website, and if you search the IEC 61439, all these standards are already adopted in India. 61439 Part 0, which is talking about the guidance to specify the assembly. Part 1, general rules, and the other subparts. All these things are there in, and you can also look at the cost. Please note that most of the IS standards you can buy it free of cost from BIS website, whereas these standards, since it's a dual standard, IS, IEC, you have to pay a little bit money. The Part 0 is 680 rupees and Part 1 is 1,840 rupees. So you have to pay a little bit and you have to take it. Now, my job is to moderate the program, but before going to the question, I have a question. Maybe, very simple question. I'm showing you on the screen 61439 Part 0. which is the guidance to specify the assembly. So means the users as well as the consultants, they should use part 0 and they should select the parameters from this part 0, or it's simply guiding them how to select a or how to make a good specification. So now here, if you go to the Annexer C talks about the specification template. So that means you can see in the screen. So it starts as C1. There are several requirements, so many requirements which need to be specified by the user or by the consultant. Let us start with this electrical system. Type of system earthing, then some clauses are mentioned here. Manufacturer standard selected to suit local requirement, TNTT, TNC, TNCS, IT. And then user requirement. User should specify this. Now, I take you to the next standard, 61439, which is the general rules. Let me go again to the same, the template, Annexer C. Annexer C, the first parameter to be specified according to this annexure is type of system earthing. It is references clause 5.6 or 8.4.3.1. Let me take you to 8.4.3.1. I hope the screen is visible. So the clause 8.4.3.1 is visible, Mr. Abhijit?
Yeah.
Okay. So now the installation condition. The assembly, this is the first item to be specified in the panel board. The assembly shall include a protective measure and suitable for installation designed to IEC 60364. Basically, it's nothing but our IS 732. When a TT earthing system is being used in the electrical network, one of the following protective measures shall be applied in the assembly. Double or reinforced insulation in all conductors, incoming cables up to the supply side of the first RCD in the system. That is not requirement when a class 2 assembly is used, or a residual current device protecting the incoming circuit. Now, such provisions are subject to agreement between user and manufacturer. So now basically my question is, to Mr. Abhijit. Abhijit, you are aware that most of our electrical installations are, looks like a TT system. It's not really TNS system. Looks like TT system. Now, in this case, how does these specifiers are selecting or specifying the first technical requirement in the standard?
See, to be very honest on these things, it's, as you said, it's very difficult to get compliance on the TNS system. Though it is supposed to be, TNS with protective multiple earthing is supposed to be the system that should be followed. But as most of the things are following TT, the only thing what we can do currently, since the things would be high, would be specifying an ELR. We cannot. It's very difficult to understand, let's say, measure the fault loop impedance, understand whether a tripping is possible or not, or even insisting on double reinforcement. Most of the times, as consultants or specifiers, we would simply specify ELR in order to ensure that at least the operator safety in terms of, let's say, the direct contact we can resist.
Okay, so you see, I was also going through several of the specific, but the first parameter is not very well established or very well clearly specified in most of the majority of the cases. I hope you agree to me, sir.
Yes.
Mani sir, what about your opinion, sir?
Yeah, I mean, I'm honestly not very clear about this part of the standard. But yes, there is ambiguities which will need continuous clarification, and it's good for such platforms to discuss these and move forward.
Yes, thank you very much. Now let us go to the question answer. There is a question from Mr. Pradeep Mani. So I don't know who can take up the answer. The question is, any mention on different material combination in busbar? Does the standard talks about this bimetallic subjects anywhere in the standard is the question. Where breaker contact are copper and aluminum, busbar is aluminum. Any guidelines or combination of different material used in the panel? One of the site is reaching 120 degree in 75% loading. Hotspot observed where aluminum and copper meeting points at backside of the breaker. So, Mani sir, any answer for this? Sir?
Yeah, it's number one is to the best of my knowledge, the standards are silent about whether you use copper or aluminum. In fact, what it says at one place is that if you're using uh, if you have type tested it for aluminum and then you want to use copper, you have to use the same cross section, which is absolutely crazy standard, which will need to be relooked at. But when it comes to the use of aluminum and copper or any other bimetallic busbar current carrying conductor in the switchboard, the most important thing is number one, you got to check whether the copper or the aluminum is electrolytic grade, as I had mentioned. If it is electrolytic grade, then it's easy for you to give all the calculations and the verification becomes easy. But the moment you play around with commercial grade of aluminum or copper, then this increasing it to 120 degrees and beyond, it is bound to happen. So there are some very small handheld equipment available for just about 75,000 rupees, which will help you to check whether the copper or the aluminum is electrolytic grade or commercial grade. So I think that is the key. And then, it's when you use a alloy, then it doesn't, you'll have to arrive at your own system of trial and error to understand what is the temperature rise. This is my take.
So in the part 1, clause number 10.2.2.5, verification by comparison to reference of design, what is written is similar enclosure parts and internal ferrous metallic parts, irrespective of their shape and size, are covered by the corrosion test on the representative samples if they are manufactured from the same material and within the same surface treatment using the same manufacturing process. I think somewhere it's not very straightforward, it's not written, but in a different way. Probably it may be referring to some of the ISO standards on how to handle this. So thank you very much, sir. Now, Mr. Saurav Das is asking please share some insights on 61439 clause 7.1.2.1, which states about atmospheric condition for indoor installation. As per the information, is it crucial to monitor both temperature and moisture simultaneously inside the panel? Let me show you what exactly, let me show you that particular clause. It is 7.1.2.7. I hope my screen is visible.
Yes.
7.1.
Yeah.
Pollution degree. 7.1.2.1 is the question, but there is no 7.2.1. Or 7.1.2.1. There is no such clause. Only up to
He's probably referring to pollution degree 1.
Yes, it's talking about pollution degree 1. Any answer from any of you? Mr. Abhijit, any answer on this?
No, I actually didn't understand the question in terms of.
The question is, please share some insights on this particular clause, 7.1.2, which states about atmospheric condition for indoor installation. As per this information, it is crucial to monitor both, the question is whether to monitor both the temperature and moisture simultaneously inside a panel, is the question. Do we need to monitor temperature and moisture inside the panel, is the question for indoor.
Normally it is monitored to have compliance to during operation, like we have limits to temperature rise inside the panel, and definitely moisture inside the panel would also be a hazard. So primarily we would be monitoring it that way, but I am not aware if there is any clause which is mandating these. Temperature monitoring is again a practice which is followed to ensure that we have the right temperature rise over ambient.
Yes, I think
my take on this is that we are basically talking about clearances and creepage distances, and which is the panel where you don't have to worry about the clearance and creepage distance is a panel where the conductor is completely insulated. Like if you take in low voltage, I have seen some of the X-energy panels overseas where the RYB neutral bus bars are completely insulated. Even the joints are completely insulated. In such cases, the concern about clearance and creepage is not of any relevance. This is my take. I'll need to study further in order to see if this is what it is.
I think we need to deep dive into the standard, and we need to have more discussions to understand more and more. Yeah. Now let me go to the next question, Mr. Pradeep Mani. Any method to identify connectivity issues between bus bar, hotspot temperature on? I think it is the first question, but in a different way. Again, between different kind of materials, how do you handle or in the joints, how do you handle the bimetallic effect? Is the question. Is there any IEC standard with acceptable limit? I think we already answered for this particular question. Let us go to the next question. Mr. Bera, in the MCC panel, is there any guideline on any specific dimensions of cubicles maintained so that installation of FSU, DOL or star delta, starter contactors, OLR, other control contactors may be installed with sufficient space for inspection and maintenance? Is it? It is also experienced that control wires connected with ammeter, push button switches, indication lamp may touch with switchgear and cubicle body, which may lead to the short circuit. So, Mani sir, it looks like a statement rather than a question. Can you throw light on?
So, these are basically to do with better practices of panel building. And, these are very difficult to be covered in any standard. As a panel board manufacturer, over a period of time, you develop a knowledge in terms of what should be the gaps between, say, for example, you take a star delta starter, what is the gaps between the contactors, the overload relay, the switchgear device, and the terminal blocks which comes out, and the differentiating between the control wiring and the power wiring. All these things are, I would say, it will need to be covered in the best practices. And, when you look at the IEC 61439 type tested, for example, we have done the type testing of PMCC. So, which means the starter feeder, when you do the type testing, you know that for a particular given rating of the starter for a given dimension, the panel has passed the test. So when you're going to replicate this, then you'll have to extrapolate it in whatever way you can in terms of ensuring that you're going on the higher side, not on the lower side. So this is the reason why I'd like to recommend to consultants very strongly that they'll have to go through all the pages of the type test certificate so that they're able to understand what exactly is the GA drawing which has passed the test, what exactly is the dimension of the enclosures modules, each module which has passed the test, and the one which is actually being used for that project, is it having a relevance to this dimension?
Yes, I think this will be more explained probably in the clause 8.3, which is talking about clearances and creepage distances. So if
clearances and creepage distances are more to do with the current between the current carrying bus bars. The question was, what is being asked is in terms of how do you arrange the switchgear devices inside the module such that one doesn't overlap on the other.
Okay, got it. Thank you. Now the next question from Mr. Manish Gupta. Can you please elaborate on type 6 and type 7 cable connection to panels? Also want to know whether these are specified in standard. Type 6 or type 7 cable connections to panel.
I mean, he's probably referring to the Form 4B Type 7. So when you talk in terms of Form 4B Type 7, we are talking about the entire panel. We have the switchgear incoming separate, isolated. We have the busbar chamber isolated. We have the switchgear individual modules isolated. And then outgoings, individual terminal blocks termination points for each switchgear is taken out into a box, which is again taken out to the various load. Now, the places where Form 4B Type 7 are insisted upon is areas where you anticipate that when it comes to maintenance of the panel tomorrow, you will be in a position to access one outgoing switchgear while the other outgoing switchgears are live. And in order for you to do that, you ensure that each one of the outgoings are isolated. So this is the concept.
Okay, thank you, thank you. Question to Mr. Abhijit. SC extrapolation or interpolation? Question from Mr. Vinod. I think it's short circuit or?
Short circuit. So listen, even these days, predominantly, what as consultant, what we are asking is we do need the same rating. Short circuit के लिए, as of today, at least in my specifications, I have not allowed for extrapolation and interpolation. But maybe what the standard asks, maybe Mr. Ramni could shed more light on this.
No, the standard is allowing you for short circuit on as tested, and then it also allows you for the verification or calculation 1 and the 2. I don't recall which one that is. So I think I will need to study on the exact answer for this and revert.
Okay. Yeah, thank you. Thank you. So probably there is a scope for our part 2 of this webinar because the number of questions are, it is jumping.
Absolutely.
Up. What is the difference between comparison and evaluation? Question from Mr. Ashok Kumar. Actually, I don't understand the question. Comparison and evaluation.
So you'd like to take it, Mr. Abhijit?
No, sir, better you can take this.
Okay. So in IEC 61439, we have 3 methods of design verification. One is as tested, 2 is by comparison, and 3rd is by evaluation. So when you're talking about comparison, you're talking about what is the dimension of the module which has passed the test and what is the rating. As against that, what is it that I'm using and what is the dimension of the module. So this kind of a comparison will have to be done with the actual panel to what has been tested, and then justification will have to be built in the declaration of compliance as to how it is compliant. When it comes to evaluation, it's more out of, there are design rules, there are design calculations which specify as to how the temperature rise is arrived at, how the short circuit is arrived at, and along with the declaration of compliance, these calculations will also have to be submitted for proving that the design is verified and compliant.
Okay, so basically it's a part of verification. Thank you very much, sir. The question is from Mr. Bera. May please share the thermography guideline and delta temperature range.
I mean, thermography is a device which you can use to understand what is the temperature rise, particularly temperature at a particular joint. Mostly the temperatures will need to be monitored at the areas of the joint of the which are there in the panel at different places. Now, what is the delta temperature range? It will have to be defined by the original equipment manufacturer. The IEC standard will say that, okay, your ambient is this. If it is say 35 degrees, you can go above by 40 degrees. Now, as an original equipment manufacturer, based on the temperature
I think there is some signal issue. Abhijit, are you able to hear my sound?
degrees.
Yeah,
now,
Okay. Clear. I think we lost him. No.
Sir, you can continue.
So this is the delta temperature range. The delta temperature range is it is something which the original equipment manufacturer declares, and then he passes the test according to that.
Okay, thank you, sir. Again, another question regarding temperature. What is the range of temperature and humidity for pollution line of products as per 61439 part 1? Production line or product line, I don't know, production line of product as per What is the
Sir, can
temperature?
you unshare this screen, Saripo, in the thermography? Acha, you're referring to this. Okay, okay.
Yes, yes, I'm referring to the standard. So if there is a question, I can search it and
Okay.
sir, you can go
I
ahead
think
with
it
that.
is. Check that.
Mr. Abhijit, what is the range of temperature and humidity for production line of product as per 614391?
As far as what I understand, I think it is supposed to operate between, let's say, -5 and 30 or 40, I think 35 or 40 degree. This is the standard temperature at which it is carried out. And I think it is the standard humidity is normally considered to be, I think, 95% ROH. But again, I'm not very sure on this. But these are these STPs normally defined 40 degrees Celsius, and in India, we're defining it at 40 degrees Celsius and 95-degree humidity.
I think in
Yeah,
the
I think
most,
upper limit is given at 40 degree. Yeah.
there is a range. You can see the relative humidity, there is a range of various ranges are given in the standard. So the the specifier has to select according to his requirement. Similarly, temperature also, normally for example, if we look at the basic the IS 732, several multiple ranges are given. The user should specify what he is looking for. Accordingly, some adjustments in the manufacturing process should be made. Thank you. Now, Mr. Pradeep Mani, any standard reference for acrylic sheet which is used in electrical panel?
Yeah, the standard I told you, it talks about the thermal withstand capability of all components which are used in the panel. So if you're using acrylic, then you have to ensure that it passes the blow wire test somewhere in the range of 600 degrees centigrade, if I'm not mistaken. So there are it is specified in the standard as to what should be the material which you can use in a panel and which you cannot use in a panel. If it doesn't pass this temperature blow wire test, then you cannot use it in the switchboard. So this is what the standard says.
Thank you. Thank you, sir. Question from Mr. Ashok Kumar. To me, can you share any government document which specify the mandateness of IEC 61? It's already shared. As I will again show it to you. This is from the regulation. Regulation 14, sub-regulation 2 and 3. 2 says every electrical installation shall be as per National Electrical Code, National Building Code. Sub-regulation 3 says every product used shall be as per the Indian standard, as per the relevant standard. Now, here the applicable standard is IEC 61439. Even though we put as IEC 61439, it's actually an IEC standard. It's a dual standard. India already adopted the standard. So the next question, what is the maximum height to be maintained for PMCC panel?
So generally in the market, it goes up to 2,400 mm. The criteria which needs to be borne in mind is that when you're standing in front of a switchboard and you need to be operating the switch gears, you need to be reading the meters, it has to be at a height where you can do all these things without the requirement for a stool. So 1,800 is specified in certain tenders. Certain tenders goes up to 1,900 for the operating handle height. So if the operating handle height is 1,900, then we talk in terms of approximately a maximum of 2,400 mm for the switchboard height.
Yes, from the accessibility point of view, I think clause 8.5.5 is talking about the accessibility, and the operating heights are mentioned somewhere. I think 2.2 meters. Okay, anyway, there is an information already.
I think 1.8 meter is the operating height which is maintained, because the primary difference between IC and what Indian conditions are, IC is based on in a country where the standard height of people is much more than what is there in India. So in India, we generally keep operating at 1800 mm.
Okay. Good. Thank you. Thanks for the answer, Mr. Chowdhury. Does substitution also involves type of ventilation, forced or natural?
Yeah. When we talk in terms of device substitution, we are talking about the device getting substituted. So most of the conditions are based on the device. If it were to have been type tested with forced ventilation, then you have to follow forced ventilation. If it were to have been type tested with natural ventilation, then you have an option of going either for natural ventilation or forced ventilation. So it's got to do more with the device.
Okay, so clause 10.10.3.5 functional temperature rise consideration for device substitution that is explained in this clause. I hope this is the one. Maybe the participants can refer the standard and this particular clause. The next question, Mr. Saurav Das, please share some insights on 61439 1.7. I think we already answered this question.
We already answered this, yeah.
Yes, we already answered this question. Mr. Vinod Panjal, what is minimum clearance required as per IEC?
So we are talking about the minimum clearance between conductors. Current carrying conductors is what I assume. And depending upon the voltage which the switchboard is rated for, the distances which are specified between current carrying conductors will differ. And there is a tabulation for this, which I'm sure you'll find it in the IEC standard as well. Most tenders which come in, they sort of add a cushion to it, and then they say that we need 19 mm as the distance between conductors. So it will depend upon each consultant's risk-taking ability and safety wanting aspiration.
Okay. Any chance? Do you remember the table number, sir, so that I can show it on the screen so that it's easy for the users to understand?
The standard distances specified are between two bus bars are 25 mm and bus bar to body is 19.
Okay.
Yeah. So that, yeah.
But it depends. It depends. These are what the standard specifications values put up in standard specifications.
Okay. So here the 3-page distances. Okay. I think the distances in the table are 3-page and clearances, not exactly how much millimeters between something like that. Okay. Anyway, let's go to the next question. What is this question, Mr. Vinod?
You know, he's asking whether for the IP, when we check the first digit, we put a lot of pressured powder on top of the panel inside a chamber. So he wants to know whether it is talcum powder. I would imagine that it is something similar to talcum powder.
Okay, so I request if somebody asks a question, please make it a little bit elaborate. Otherwise, sometimes we also will be confused on the questions. So, thank you very much. How arc flash compliance is taken care of? Mr. Abhijit is the question.
I'm not aware of how arc flash compliance has been taken care of. What 61439 has, let's say, not a mandatory and optional test for internal arc. So you can have panels which are internal arc tested. However, arc flash itself, I think, has an entirely different standard and a different procedure dedicated to it. So when we talk about 61439, we talk about internal arc.
Yeah, I think the word arc flash itself doesn't exist.
No, I don't think that it's in the standard.
Yeah. So there are certain devices available with, I'm aware of from ABB, it's called Arc Guard, and a similar kind of a device is available with Schneider also, where you have various sensors fitted in different parts of the panel where you expect an arc flash to happen. And this device is able to identify the arc flash, communicate it to a mother device out there, which is called the arc guard in this case. And this arc guard, the moment the flash is received, the information is received, it trips the incoming breaker. So I do not know whether the question was aimed at that, but such devices are available in the market.
Thank you.
So you can also have a device which can take up, let's say you have, instead of bus bars, you have cables connected. So there are devices which can identify the fumes coming out of overheating of cables. So even such devices are also used for arc flash mitigation certain times.
Okay, in that case, I have a question to both of you. Are they as per any standard or proprietary products of the manufacturer?
I don't know.
Mostly these are devices which are very rarely used, and I'll have to check with the device if complies with
Yeah.
particular standard.
Because most of the time, unfortunately, in electrical engineering, most of the time, business is happening because of by creating fear.
Yes.
So very difficult. Okay. So, the question from Mr. Rahul: for an IP64 rated panels like fire pump panel or water pump panel, can we test all the tests as per IEC 61439? IP64 panels, can we do all the tests as per 6143? Of course, I think yes.
Yeah, you can. It's a question of taking care of the temperature rise. And as long as you are able to size the enclosure and whether you want to give a forced ventilation arrangement to take care of the cost element involved, then it is very much possible.
Okay, so what is the maximum IP tested with Modutech panels and with which switchgear? Question from Mr. Mani.
Yeah, so we have got it type tested for IP55, and this is with LS switchgear. This was done in Seoul in South Korea under the aegis of DECRA laboratories, DECRA certification.
Okay. Mr. Vinod, again, bus bar for testing which is coming out of panel should be copper or aluminum. The bus bar which is coming out, bus bar for testing which is coming out of panel.
Correct. So that has to be copper.
Okay. Can we get TTA assemblies for panels with the outdoor panels better than IP55? From the question from Mr. Janagi Ram. Can we get TTA assemblies for panels with outdoor panels better than IP55?
I think the concept of TTA first is obsolete. What you mean perhaps is whether you can get IEC 61439 compliant assemblies, and the answer is yes. You can get it type tested for IP55. It is just that it's a question of how you manage the temperature rise.
Okay, thank you.
Enclosure size will become bigger. That's all.
Again, Mr. Question from Mr. Subrat Kumar. IP54 and above is for flame proof or not? Flame proof and a question mark. It's not for flame proof, it's for dust and moisture, basically.
IP54 is for dust and water ingress or liquid ingress. Flame proof is a different concept altogether.
Yeah. Okay. So we know, can salt spray test to be done on specimens?
Yes.
I think specimens only it is made because you cannot make salt spray in a big panel. The chamber of the salt itself is very small. So you cannot put the entire panel into it. So is salt spray testing same for indoor and outdoor?
Yeah. It is the number of hours which will differ. So it is the same. You've got to give a representative sample, put it inside the salt spray chamber, and then depending upon, if you look at a tender specification, it would clearly define that the enclosure, whatever parts are used in it, should pass 500 hours of salt spray test, 1000 hours of salt spray test. So depending upon the severity of the environment in which the panel is placed, the number of hours of salt spray test will get defined.
Yeah. Okay, thank you. Now there is a question regarding seismic compliance. I am just searching the clause number in the standard 7.2. It is mentioned the panel should withstand vibration, shock, and seismic occurrences. I think only in one clause, 7.2, special service conditions. So is what is written. So we know the clause is 7.2. But it is not speaking any specific test conditions and all. It's just mentioned in the standard. Mr. Puneet Goyal is asking if the client requirement for 5,000 amperes or 6,500 amperes ACB in incomer, then panel will be constructed as per 61439 or not.
Yeah, most certainly it will be constructed as per IEC 61439. If you have type tested for 4,000 amps, you cannot extrapolate to 5,000 amps or 6,300 amps. You have to necessarily get the 5,000 amps and 6,300 amps type tested. But if you have type tested it for a higher rating, you can extrapolate it to a lower rating. So this is what the standard says.
The best way is you can look at the scope of the standard. Every standard has got the clause number 1 is the scope, which explains where this is applicable and how this is applicable. You can look at the scope where the applications are very clearly mentioned. Of course, irrespective of current, it is the compliance is required. So, question from Mr.
I'd like to add here. One thing I'd like to add here, that in case if they're feeling that IC 614 should only be limited to 5,000, 6,300 ampere, it's not. I would say that even a small single phase DB of 25 ampere, which you're putting in a house, should also comply to 649. Let's say part 3.
Yeah. Correct. Thank you. Question from Mr. Shyam. How does end user ensure OEM 61439 panels are made without any deviation from the tested design? I think it's
you have to refer the tested design first.
That is, you see, 2 points I brought out in my presentation. One, the consultant will have to ask for all the pages of the type test certificate and go through it to check whether it is compliant with the panel which has been manufactured. Number 2 is that they'll have to ask for the declaration of compliance. So once the declaration of compliance is submitted, then it becomes easier for the consultant to verify.
Yes. I think the best way is to look at the Annexure C of the standard, where the user information template is given. So sample what the user look for is given. Table C1 is intended as a template for the identification of items necessary for the assembly manufacturer, which is to be provided by the user. So the user's demand is specified here. So am I correct or maybe I'm wrong?
No, this is when it depends on whom you're talking about as a user. I don't know whether it is referred to by, whether the reference is perfect. So the user, it will be more on the application installation side is what I reckon.
It talks about the first one is electrical system, which talks about voltages, transient, voltages, rated frequency. That means the electrical parameters. Second is short circuit withstand capabilities. Third is compliance to the IS 732 standard. Then installation environment such as location and IP, IK and all. Then it talks about humidity, altitude, all this installation method. How the installation is going to happen, storage and handling, operating arrangements, then maintenance and upgrade capabilities, current carrying capacity. So this is a very exhaustive requirement. So technically, I think the specifier should look into all these parameters and in order to make a good specification. Now let us go to the second question. The next question. Does IEC standard require us to go to certification bodies or test labs are good enough? If yes, which clause?
So there is what is called the ISO 17025, and that refers to laboratories like CPRI and ERDA. Of late, CPRI has also taken 17065, an ISO document which talks about certification. So there is a difference between certification and laboratory testing. In a laboratory testing, it's always black or white. You've asked me to test for this parameter. It has passed the test or it has failed the test. So these are the only two criteria. In fact, I remember once we did a type testing, we went to the laboratory, ERDA directly, and we had covered almost 8 to 9 tests, and then the 10th test failed. Now, ERDA said that they will not recognize the passing of the 9 tests which has happened successfully, and they can only give a failure report. So then what we had to do is we went to ASTA, repeated all the tests. Now, the beauty of ASTA, or for that matter, DECRA, KEMA, etc., they're all certifying bodies governed by ISO 17065. And when they are governed by ISO 17065, they will allow you to repeat a test if it fails. And they will, of course, have an observer there all the time and ensure that there is no hanky-panky done. And it is, passed again. Then they take it to the completion of the test and then they give you the certificate. So it's very important for us to understand this distinction. Today, CPRI has also come under 17065. So panel builders can avail of CPRI for the Indian markets majorly.
Thank you, sir. I think in the standard, this is explained in clause 10, which is design verification, which explains, all the at the design stage, verification parts. Then routine verification. Routine verification may be the actual test which is carried out in the laboratory. But if we look at the design verification, for example, protection against electric shock. One moment. This is about in 10.5. Protection against electric shock. It's a verification. It says, the verification, with a continuity meter, with a micro ohm meter, you should test the resistance between different exposed metallic parts, and the resistance should not exceed 0.1 ohm. I think this is a mandatory requirement. So probably different type of tests are mentioned in the clause 10 and 11. I request Mr. Vinod to look at these two clauses for more information. Hope I am correct, Mr. Ramani.
Yeah, you can. I would imagine that you're touching upon it from a different aspect. We can move forward.
Yeah, thank you. Thank you. So we have any design software for panels? Question from Mr. Narendra. Any panel design?
So from Modutech, we have design software which is called ModSim, and that helps you in the estimation of the software, as well as it takes you to the bill of material, which in turn gives you the clearance for execution in terms of development drawings. So I'd be happy to address this one-on-one and take it forward.
Actually, we have still another 33 questions, and people are again more and more questions are coming up. But it's time. More than 2 hours is really, it's a little bit. So I would like to stop taking the questions, and probably if anybody wanted to have a chat, or anybody wanted to have a question directly with the team, maybe the first come first serve basis. If you raise the hand quickly, we can take 1 or 2 questions. Oh, Mr. Davis said, Mr. Davis, you can speak.
Yeah. Thank you, sir. It was an excellent presentation on panel, this IEC 61439. But here I have a question, because I have come across many times the panels at site are failing because of improper installation and commissioning. Suppose maybe a panel is IP44, but at site you find that it's not properly closed. So, and something ended inside, or the gland plates are. So, is there any standard which specify for installation commissioning?
Sir, can you repeat the question? Is there any
installation commissioning standard, basically IEC or IS standard, which talks about, okay, this is installation and commissioning to be done with respect to this?
Yes, that is the installation standard, IS 732.
Okay. IS 732 covers the installation practices?
Yes. It is not like the technical requirements are specified. It is not like you should tight it with this much torque, this much space. That kind of requirements are not given, but the overall technical requirements are given.
No, yeah, normally panel failures at site happening because of the proper tightness not done, or the gland plates are kept open, or the doors are not closed properly, or the alignment leveling is not proper, and that's what I want to know about it.
Thank you, sir. We have Mr. Milind Sardesai and Mr. Arfat. I have made both of you, you can speak, Mr. Milind. So Milind, if you have no question, we go to Mr. Arfat. Yes, Mr. Arfat.
Yes, sir. Yes, sir. I want to know, sir, how many layer of bus bar we can use in single phase, in copper and aluminum.
How many numbers of bus bars?
Yes, yes, sir. Bus bar
Uh,
layer.
so, that is one run. How many runs of bus bar you mean?
Yes, 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 sir.
I have personal experience of going up to 8 runs of bus bar per phase. Beyond that, whether it is possible, I mean, technically, I don't see why not. But end of day, what is it that we want to achieve is what we'll have to look at. We want to ensure that it is properly complying with the various requirements of the standard. So that's what I have to say.
This is Milind Sardesai from Goa. Can you hear me, sir?
Yes, please.
Yes.
Yes.
Yeah, this was a very excellent and informative webinar, and it is worth watching more than once. Will you please put up the link on YouTube so that people can watch it? Very
Of course.
educative.
All our webinars are available in our YouTube channel. You go to NFE YouTube channel, all the informations you can see.
Okay.
But
Thank you,
you
sir.
know,
Thank you.
there sometimes some of the very technical subjects we restrict for members only. That means only NFE members will be able to view it. So
I am a member, sir.
yeah, if you are a member, of course you can access every.
Okay. Thank you. We met at Goa at Mandovi.
Okay, thank you, sir. Thank you, sir.
Okay.
So some more hands are raised. Let me allow one more person, Mr. Amritlal.
Yeah. Good afternoon.
Good afternoon.
Good afternoon.
And the question is regarding the care rating of the panel, whether it depends upon the consumer to manufacture or is it mandated by the standards? That is the first one.
Completely depending on the application. So you the fault level will depend upon what is the fault level which is existing or likely to exist in that particular circuit, which will again depend upon the size of the transformer which you are going.
So it is by the consumer.
It is by the consumer. Consumer in the sense the consultant and the
consultant. Yeah.
Consultant.
Okay.
Yeah.
That's fine. Now the second part of it, the care rating. Suppose if I am saying 25K rating, does that mean all the components are rated for 25K in the panel?
Absolutely.
In the
It
power
has to.
circuit, yes.
In the power
Even
circuit.
the control circuit?
No, the control circuits are protected by the power circuits. So as long as the power circuit is able to take that 25K fault, the control circuits are protected.
Usually the control circuits are tapped from the incoming side of the panel. This is what I see. And even the branch bus bars sometimes usually find a reduced section size.
No, see what happens is specifically with control circuits is the cross section of the wires used for control circuits will actually reduce the fault very significantly.
No, I am not talking about the wire size. I am talking about the breakers. Like you usually see 10K MCBs placed for control circuits instead of using HRCQs. Whether such type of testing or calculations are required for IEC testing?
I don't think so.
This is a question I would like to ask, because in big panels from the incoming breaker, such big bus bars, a small 1.5 square and 2.5 square of wires are taken and MCB is put for indicating lamps and other
That is what I am saying. Yeah, same question.
So what happens is when we talk about short circuit, it is a prospective short circuit, and a prospective short circuit. See, when it prospective fault happens, so when we are talking about control circuit, the fault might happen either at a lamp or at a meter or somewhere, and the prospective fault at level at these would be much lower. And even if a fault happens before the MCB, anyways, it can't protect it.
No, I don't think that is the right way to do it.
What is your
I have
opinion,
seen,
sir?
yeah, I have seen panels where you have on bus bar mounted HRC fuses. Then from the bus bar mounted HRC fuses, you tap the wires. So the breaking capacity is taken care by the HRC fuse.
I think instead of small MCBs, HRC fuses with sufficient breaking capacity shall be used.
Yeah.
Am I correct,
Yes,
Amrit?
yes, yeah.
I,
And
I
also,
agree with
if
you.
it
I
is
agree with you.
possible,
That
yeah,
sounds fair.
If it is possible, you put up a 1:1 transformer after the HRC fuse, then you can reduce the fault level, and for further control circuits, you can take 10K MCB if the secondary fault level is 10K.
Yeah. Thank you. It's like a
Yeah. One more question. Is there any, constraint regarding the material of construction, like IEC 6? This particular IEC stands for only metallic enclosures or all enclosures? Polycarbonate enclosures also.
If
Hello.
I'm not mistaken, it does cover polycarbonate enclosures also. I do remember having seen a Hensel IEC 61439 website on online where Hensel, which is thermoplastic enclosures, also talk in terms of IEC 61439. So IEC 61439, to the best of my knowledge, it is more to do with the 12 tests which have been specified in the in the thing. So for IK test, it may not go up to IK 10. It may be maybe IK 8 or lesser than that. But
not only IK, I am worried about the temperature rise also.
Temperature rise also, you will have to take sufficient volume of air inside the enclosure to comply with the type test.
I think it is applicable for all the panels, because now only I remember we also have this plastic IP65 assemblies.
Yes,
so
yes.
CPRI up to, I think, 250 amps, but smaller ones up to 250 amps it is tested for IP, temperature rise, short circuit, as per the standard. So it's not the standard is not restricting to metal.
Right.
Okay.
Thank you.
Thank you.
Last question, Mr. Dinesh Chandra. So Dinesh, any question? You have to unmute and speak. If there is no question, then probably Mr. Dominic, you would like to make a conclusion?
There is one gentleman who has reached out to me on my WhatsApp asking me that my questions are not being answered. So if you permit me, I'll quickly take these questions.
Of course, yes.
This is of Sudeep Sanyal, and he says, does every rating above 1600 amps need to be tested by the independent lab, Asta, Kima, Asifa? The answer is that as per IEC 60439, which is today obsolete, it was required. But today with IEC 61439, it is not required. If you do it for 4000 amps, all the ratings below are automatically covered by that. You can even do 6300 amps as what your customer base would opt for. Second is, can we use two OEM products in the same TTA board? Example, Schneider switchgear and Siemens IMCC controller, like SimCode. The answer is again, when it comes to switchgear, you're talking about Schneider switchgear. So that's fine. SimCode is a device which you're adding to the entire control wiring part of the panel. So therefore, whatever is relevant to IEC 61439 would be aligned with Schneider Electric, and the control circuit part of it, it will be at the discretions of the consultant. But whether you can use a Schneider ACB and a Siemens MCCB, the answer is no, as of now, as far as the Indian version of the IEC 61439 is concerned. So, the extrapolation of that was, can block set be used with SIMO code of Siemens? The answer is yes, it can be, because SIM code Siemens doesn't really come into the purview of the IEC 61439 per se. There will be certain extrapolations which the consultant will have to take a case-to-case decision on whether to allow or not to allow. That's it.
Yeah, thank you. Thank you very much, sir. So over to you, Dominic, sir. It was a very nice program.
Yeah.
Yes, sir. It was very wonderful. It's a different topic, as if you've seen other topic that we are covering. So this is something very encouraging. Just a second. Yeah. So we are having next week we're talking about lightning protection. So we have a very interesting subject that is coming up next week. And our next webinar, the physical seminar is happening in Indore on 18th on National Electrical Code of India. So I would urge all the members who are here, who are keen interested, to join for our future webinars. We'll be sending the message to you. And also, I urge all the members, very good participants, and they very patiently waited for 2 hours, almost 2 hours for this webinar. And I would appeal to everyone to become a member of NFE. My colleague Lakshmi would have probably typed the link to become a member of NFE. Our intention is to touch 5,000 members by March. So that's the goal. So we want every electrical engineer in the country to be part of NFE, because our motto is very clear. Where there is electricity, we need to have a chapter, we need to have an aggressive member there to make sure that electrical installations are safe and we practice safe, electrical safe practices. Thank you very much. God bless you all. And thank you, Mani sir, and thank you, Abhijit, for your support and interactive. And thank you, our president, Mr. Gopakumar. He landed at 3 o'clock in the morning, and we are on the front of the camera. Half a day is gone. I'm sure family will not love all this, but the work that we are doing, I'm sure, at the end of the day, it's something that you can always feel that we have done something in society. So thank you so much, all. Have a wonderful day. We look forward to see you again. Thank you so much.
Mr. Dominic and Mr. Gopakumar, really fold my hands to appreciate the amount of work which you are doing, the amount of sincerity with which you are approaching the subject, the consistency with which you're conducting one webinar after the other, the involvement which you all have at a personal level to ensure that this is successful. I think India definitely and the world needs more Dominics and Gopakumars to be evangelists for safety, protection, and the compliance in the electrical circuits. Thank you.
Such comments definitely motivates us, inspire us to do much better work. But one thing I would like to tell the audience, every webinar, we always feel maybe next webinar we may, the count will come down. As people have stopped doing webinars on Zoom or virtual. But very surprising that every webinar, we are encouraged to see minimum 400 to 500 registration. Out of that, 60 to 70% turnout. So we always think, I think next after 3-4 months, we'll not do virtual because count is coming down. Whereas other society, when I talk to other Eastern, my friends and all that, their count is only 40, 70, 80, 90, maximum is 150. But NFE program, it's becoming more popular and people are following. So that's quite encouraging. Saturdays, we dedicated our half a day for these social awareness programs. So once again, thank you for such comments, sir. It inspires, sir. Final word from our president.
Yes, see, for making India electrically safe, one Gopakumar and one Dominic is not enough. 100 Remini Mani and 100 Abhijit are also required. Thank you
Yeah.
very much. Thank you, sir.
Yeah. Thank you, sir. Bye-bye. Good day.
Bye-bye.
Thank you.